Hello everyone. Today we will see how we can build simulated robots uh, in Gazebo and control them. Uh, so in this tutorial we will do these following things. First we'll build a simulated mobile robot from scratch. We'll control the robot motion using ROS. Then we'll visualize the robots uh, in our ways. We'll add sensor to the robot, and finally we'll see the autonomous navigation of the robot. For this you need a working ROS and Gazebo installation. You set up the Catkin workspace. I have tested the programs on Ubuntu 18.04 with ROS Melodic, with Gazebo 9.0, but most of the commands should work on the previous versions like Kinetic as well. Okay, so our first step is to build the robot. For that we'll create 3 ROS packages inside the Catkin workspace slash src folder. So we create Gazebo packages, ROS packages using Catkin create package command. So we create 3 packages: skboard Gazebo, skboard description, and skboard control. Skboard Gazebo depends on Gazebo ROS. So once you create this, your next step is to create your own world. So you go to ROS cd skboard Gazebo, and inside this one you create 2 folders, launch and worlds, and inside the worlds you create a skboard.world file. So before we go forward, we'll just see that Gazebo ROS is installed. So we can run this command: ROS launch Gazebo ROS and empty world dot launch. So this shows that Gazebo is working. You are able to see an empty world. Okay, fine. So I will not run all the commands here. You can do it by seeing these slides. What I will do is that I'll go through the steps and show you the final outcome of all the steps that we will explain now. The entire package is available at the GitHub site here. So for this part of the tutorial, this is the first part where we build the robot. You just have to clone the master branch of this one. So essentially the first step when you create, for example, you go to cd Catkin workspace, then you go to src folder. Most of the packages are installed here, and then we run Catkin make. So my package skboard is available here. So when you download the entire skboard package, this Gazebo experiment package, if you download, then you will have these folders. So that shows you skboard control, skboard description, skboard Gazebo, and skboard navigation. But for the master branch you may not have the navigation, so we'll talk about it later. You may not have also skboard. You just have these 3 packages that we're talking about. You don't need the other 2. So let's focus on these 3 folders that we're talking about. So when you create it, you have these 3 folders: skboard control, skboard description, and skboard Gazebo. Now if we go skboard Gazebo, you see you create 2 folders called launch and world. So you have this launch and world file here. CMake list and package .xml is created by Catkin create package command itself, so we don't have to write these files. Now inside the cd worlds we have a file called sk.world. So your basic sk.world file looks like given on the right. This looks like as simple as this. So you have XML version, you say SDF version something, and you give a name to the world, and what it includes is a sun, model sun, and a ground plane. That's it. So if I see it here, gbeam skboard.world, you see you have one model sun and another is model ground plane. Rest of them are commented, so need not worry about it. And all the items are mentioned within these tags, world and /world. So within these tags these models are included. You can include other models are available, we'll talk about it later. These models are available with Gazebo and we can load them, but we'll talk about it later. So our world file is ready. Your next step, so if once we have created this package, we'll create a launch file. In the launch file is used to load this world and everything. So what we do now, we go back here. Now we go to launch file, and then we have this gvim skboard launch world.launch. It has many things. We will write at the moment. We won't worry about them. So a basic file will look like this. You have one empty world.launch file, and you load this skboard.launch skboard.world file. So what it does is that simply loads the skboard.world file. So if we see our file, this is a modified one. Let's see the other file, gvim skboard.world2launch. So you forget about the all other commands here, you just focus on the first part here. So what you can see is that it loads the empty world.launch and then it loads the skboard.world file, which contains a sun and a ground plane. That's all it contains. For the moment, the time being, you forget about everything else. So if I really comment out all these things, for example, if I do this, so I commented the everything out of this, and I leave these 4 lines in the beginning as explained in our tutorial. And if I run this command now, ros launch skboard gazebo and skboard world.launch, let's see what happens. So we go back, so we say ros launch skboard gazebo and skboard world2.launch. See, the world.launch is modified, but the original one is skboard_world2.launch, which we just saw and commented out the other statement. So if you see this and if you run this, what you see is an empty world. That's all you see, because we load the skboard.world, which is nothing but there is a sun and there is a ground plane, so nothing else is there. So we at least completed this part. So we press Control C to kill the gazebo window. Now what we do is that we'll create a robot model. So robot model is created using something called URDF language, um, which contains all the components of the robot, and and we use xacro XML, that is called xacro. XML macro stands for xacro stands for XML macro. This gives us a shorter way of writing the XML file. That means you know you can define variables, you can define functions, you can reuse a lot of code. So that's why XML macro or xacro is used. So we'll see how it does happen. The robot descriptions are created inside the skboard description folder. You remember that skboard description is one of the folders that we created using catkin create package command. So since it is a catkin package, you should be able to use cd skboard description. In this one you have this folder called urdf. You go here and you see you have these four files: macros.xacro, materials.xacros, skboard.gazebo, and skboard.xacro. uh, so it says that you create urdf folder, and first you create the skboard xacro, and here it starts with the first line called skboard x7 as xacro, this one. So this says that this is an xacro file. Okay, so then xacro includes some of these concepts. For example, we use xacro include to include other files into itself. Then xacro property is used to define variables in constant that can be called from multiple places. You can use this constant anywhere else. Then xacro macro is more like a function that can be used to reuse a particular section of the code, and this particular line basically tells that this file will use xacro. So for example, if we see the skboard xacro, it starts with this line. It tells that it's a xacro file. Then we use xacro property to define different variables, like for example pi, chassis height, length, width, mass, wheel radius, position, caster radius, and all those things we define. And then this xacro includes these files, other files like skboard.gazebo, materials.xacro, macros.xacro. These are included into this file by using xacro include. Now the first element that we put is a chassis. We call it a link. So different components, main components, are formed into links which have a connection with each other when they have a positional relationship with each other. For example, the chassis is one other link, the caster wheel will be another link, right and left wheels will be another links, and they are all linked together to form the entire robot. So chassis, every component will start with this tag, link, and link tags, link and slash link. Each of them has a pose. There is a collision one. Collision tags are used by the collision detection engine. Visuals just gives you the appearance. Here we are using a color called orange, and this particular orange color is defined in the macro materials.xacro. So this is there. And inertia, it is used by the physics engine. So all types of dynamics, physics, gravity, and all those things are affected by this particular tag pair of tags. Now let's see. So in the URDF file, I told you that these four files are there. So let's have a look at the gvim skboard.xacro. Okay, so gvim xkeyboard.xacro. You see the first line starts with this xmlns and xacro. It says that's a xacro file. These properties are defined, then it includes the three files. This part is commented, don't worry about it. So the first part is this, is a link named chassis, and it has all these properties, uh, the collision properties, visual properties, inertial properties. So inertial properties are used by physics engine, collision is used by the collision detection engine, visual is gives you the appearance, and so on. So there are other things are there which for the time being let me comment out everything else. So I am commenting out the whole of this. I'll do it again here. So this is annoying, but what to do? I'm going to do it multiple places wherever the commands are there. Can it did not work? Fine. So we comment out all other parts of it, and we just leave the first one. And once we have done that, so this is what he says, that we first create the first file. Probably it will be better if I do the other way around. For example, I create copy xkeyboard.xacro, xkeyboard.xacro.back. In that way, what will happen is that I can simply the whole thing I delete the whole thing. I make a copy of back, so hopefully the xkeyboard xacro.back is there. Okay. Okay. Now let's have a look at the xkeyboard Gazebo. It has only you know Gazebo reference as chassis, and its color is orange, and we put it within the robot and slash robot tag. And if you see the materials xacro, different colors are defined. We'll just have a look at each one of them. Copy xkeyboard Gazebo, xkeyboard.gazebo.back. We'll just make a copy of that so that Gazebo, you see it has reference to only to the chassis. So if I comment it out, let's see if it works. Anyway, we'll remove everything else, so we have this only one reference. And then same thing with the materials or xacro. So copy materials dot xacro, we say materials dot xacro dot back gv materials dot xacro. If we see, then it has a lot of colors are defined, red, orange and everything. Nothing else is there, so that's good. Okay. Okay, so then this file is also done. So we have this escape gazebo, material xacro, and then we have a file called urdf cd urdf copy macros.xacro. So we'll make a backup of that one, back macros.xacro. So what you see here, we define something called cylinder inertia. These are like functions that takes, for example, cylinder underscore inertia takes three parameters m, r and h, mass, radius and height, and then it compute the inertial values. That means inertia around x-axis, inertia around y-axis, and inertia on the z-axis. Similarly, we define inertia for box and sphere. It defines several other macros, for example wheel, things like that. So we'll see them later, but for the time being, the top three are defined. I will not the other things do not affect right now, so or maybe we'll just comment it out just for the sake, because it's not required. And so we comment the whole thing. So so initially this has the box inertia and other things. The box inertia is used in the chassis part of it. If you see the escape or xacro, somewhere the box inertia is defined. Yeah, this is the box inertia. Box inertia is something defined in the macro.xacro file, so that's why we are mentioning it here. Now these files have been defined. Then what we'll do is that we will put some lines in the escape underscore world.launch. So if we raw cd escape gazebo cd launch and gv escape all 2.launch, and you see we had commented these lines. Now we will remove the comment. Same thing. So what it does is it loads these parameters of the robot defined in escape xacro into ROS, and the second one spawns a model into the gazebo world. So the last one we still will keep it commented. We'll talk about it later, but right now we'll just put these two lines as mentioned in our tutorial here, these slides. So we just put these two lines. Now if we run this, let's see what happens. So if we say ROS launch escape gazebo escape world2.launch, because our world file is modified, we'll go with the world2.launch. So if you do this, what you see is a brown box. You see this is called the chassis frame, and which color is orange, and it's at a certain length, breadth and height, and it is at the origin. So that's all you get by doing this first step. So this is shown here. If you do this, you get this one. So what will happen is that now we'll add elements to it. So while doing so, we'll modify this xacro file, macro.xacro file, and gazebo file. These three files will keep on changing. So for example, now what we do is that uh, we add we specify a joint is a place where two links are connected. So first is the chassis, and the second is the caster wheel. So this link, the caster wheel is another link here, and it is connected to the chassis. So for each joint will have parent link and a child link, and it will tell you it's a fixed or continuous or something like that. It's a fixed means it doesn't move. There is no relative motion between the chassis and caster wheel. That means, and in the caster wheel you have similar tags, for example collision, visual, and inertial, that define different properties. The material name is red is defined in the materials.xacro, and then we define these, and these two macros here, wheel, which actually creates two wheels, left wheel and right wheel. So it takes a the first parameter is the left, and some translation parameter is 1, and another right wheel we give -1. And these are macros. If you see it, for example, it's defined there. So in the macros file, these we define these macros wheel. Okay, so you have left, right, and this takes two parameters. And so basically it creates its kind of function. So if you say left, it creates the left wheel, and if you say right, it creates the right wheel, and it does all those things. It calls itself the cylindrical inertia, which is another macro. Material name is white, which is another macro. These are defined in different files. For example, white is defined in materials.xacro. This one is defined in the macros.xacro. And here gazebo reference is also a part of this macro wheel. So we don't have to modify at multiple places. Everything is incorporated into a single function called wheel. So this is how xacros make the file more compact and readable. So all those commands are um, hidden behind these macros. So by putting these two commands, we are creating two wheels. Okay. So after the wheels are defined, yeah, so now I think it is the file continues, the macro.xacro continues, and it includes Gazebo reference, it includes some joint values, then there's a transmission value thing. We'll visit this transmission again. This is something used by the controller, and we'll see to that later. And in the xkeyboard file, we just use the color for the caster wheel and some friction parameters. We do that. So let's have a look. So what we do is, yeah, so gazebo is killed. So raw cd xkeyboard description, cd urdf, and first we'll visit the move xkeyboard xacro dot back, xkeyboard dot xacro. So we restore the original file. So gvim xkeyboard dot xacro. So you see all these things are commented out. We remove this caster wheel is included, okay, and then we have this left wheel and right wheel. See, the other part we remain, we keep it commented. So we do this, then move xkeyboard gazebo back dot gazebo. Move materials dot xacro dot back to materials dot xacro. Move macros dot xacro dot back to macros dot xacro. So we'll restore all the files. So if we now see xkeyboard gazebo, we include a reference for the caster wheel, so where we define the friction parameters, and we choose a material called red. The other parts uh, we'll comment it out for the time being. Yes, it is annoying to put so many comments, but still continuing nevertheless. So xkeyboard gazebo has only those things, and then we'll see the file macros.xacros, gvim macros.xacro file. If you see, so initially we define this inertia macro, then we'll define this wheel which takes two parameters lr and ty. So just stay left or right, and then this ty just tells you the translation along the y-axis. So one is +1 and this -1. So this is defined. After that, a gazebo reference is included here. So this part need not be there in the gazebo dot xkeyboard.gazebo. That reference file is already included, and this joint name is also included. So you so for every link you need to have a joint, you need to have a gazebo reference. So everything is included into this one, and along with that there is a transmission part is included, which is used for controlling the robot. We'll talk about it later, but everything is included, so we don't have to change anything here. So yeah, so we are now good to go. So if we run this now, ROS launch xkeyboard gazebo xkeyboard world2 dot launch. We're still using the world2. So what you can see now, we can see the complete robot. You see, there's two wheels is there. You can use this rotation tool to rotate your robot. This is rotation along the y-axis, this is along the z-axis, and this is along the x-axis. So you see, even if you do this, it falls back because of the gravity, because it has a mass and it falls back. So if you do this, you see it falls back because the physics engine is working, so the gravity and other things. So you have this, and you can use the translation tool to move the robot upward. You can keep it here. So if you put it, take it upward, it will fall back. So that's how you can see the wireframe view. You can see center of mass, you can see joints, you can see link frames. There are various informations you can see here. So that's it, at least. So our robot is built. Now now the robot is static. You cannot move around. It's just the chassis and the mechanical part. So in order to move the robot,